Question: number of connected components in the undirected graph here is a median LEETCODE question, and basically you have a graph of n nodes and you are giving an integer n an array edges where edges I equals basically this. Looking at the example here, this is the edges, and edges I equals to AI BI, so indicates there is an edge between AI and BI in the graph, and you can take a look at here. It's 0, 1, there's a connection, and 1, 2, 2, there's a connection, and there's a connection between 3 and 4 in the graph. Return the number of connected components in the graph. So basically, we can see that this part is connected and this part is connected, so the output returned here is 2. And if you take a look at this one here, and n equals 5, edges are 0, 1, 1, 2, 2, 3, 3, 4, and everything is connected, so the output here returned as 1. And if you go through here, this is some constraints here. I think this is a pretty straightforward problem, and this is a question asked by LinkedIn, Amazon, Facebook, Pinterest, Microsoft in the last 6 months. So when you look at this problem, you can probably think that this is a problem can be solved by buffer search or depth search. Either way works. I'm just a little bit prefer buffer search in this case because I can just go through its neighbor and popping through the queue, and after I visit the neighbor and I add a neighbor to the visit set so that I won't visit the same node again. And then basically each time when I go through a buffer search, in the end, I want to go through every single node. And each time when I go through the buffer search, I want to add 1 count to the result. And in the end, I'm going to return result. And after I go through this buffer search, that's 1. And then the next time I'm gonna pass the node as a parameter to the same buffer search function, and I'm gonna append this node to the queue. And while the queue exists, I'm gonna start popping from the queue. When I'm popping from the queue, I will make sure to add the node, and if I have not visited the node yet, I will add this node to the visit set and append this node to the queue to see if this node has other neighbors. If there's other neighbors, then I will continue to make sure to visit all the neighbor it has. Otherwise, I'm just gonna stop the buffer search for this one. And then, like I mentioned, in the end, you want to go through every single node in this address here to count the total number of output. So now I'm going to show you how to do this in code. I know it's a median question, but it's fairly easy. So what I want to do is in this case, I want to use a hash map to define the edges that they give to me. There's different ways that you can do it. You can use default dict. I'm just using hash map in this case. So this is how you handle it in Python for in range n. It tells you that it has you're given an integer of n, so n equals 5 in this case. This is how you write it. And after I created this hash map, what I wanted to do is for AB in address, like it mentioned, like in the address, it gives you A, B. This number means that there's a connection here. It's bidirectional, basically. There's no direction at all in this case. So what I wanted to do is I want to map A. I want to make sure to append B here, and map B. I want to make sure to append A here. Right, so this is the definition of the graph, and after I write this hash map, it should be something look like 0. 0 has a connection to 1, and then 1 has a connection to 0, and also has a connection to 2. That's for 1 and for 2, and I have a connection to 1. Just something like this, and basically we'll go through all 4 nodes. And then what I need for this buffer search function is I will define a visit set, basically a hash set, to make sure that if I have already visited this node, that I would not go back to this node again to revisit it. So then I'm gonna define the buffer search function. I'll pass the parameter as a node because when you started, it gives you a number. It will start from the first node, right? It doesn't matter which node that you start. And what I'm gonna do is I'm gonna create a queue for the buffer search so that I can pop. And initially I want to append the node to the queue. So basically, let's say if I start from 0, right? I append the node 0 to the queue first, and then I'm gonna go through the typical buffer search, and I will say while queue exists, I'm gonna continue to iterate through it. So first thing I'm gonna do is node equals to queue pop left. I'm gonna popping from the left side of the queue. Basically, once I add the 0, I'm gonna pop it while I'm popping it for neighbor in map node. So basically this is the map, right? And then there's a 0 has a neighbor. So basically I want to say visit 0's neighbor, which is 1 in this case, for neighbor in the map node, right? What I'm gonna do is if the neighbor not in visit, if I have not visited this neighbor already, what I'm gonna do is I'm gonna add this neighbor to the visit set, and then at the same time I'm gonna basically add a 1 to the visit set, so in the future I won't visit it again. And I'm gonna append this neighbor, basically 1 to the queue here, and then so that I can continue to pop. So while queue, so the queue has 1, right? And then I'm gonna go back up and then start popping the 1, and then iterate through 1's neighbor, which is 0 and 2. In this case, 0 that I have already visited, so I won't visit again when I go through the queue, the while loop again. So then I'm gonna visit 1's other neighbor, which is 2 in this case, and I'm gonna add 2 to the visit set and also append it to the queue, so on and so forth. And after I add a 2 node, and this connection is done and there's nothing left. So basically that's the buffer search function here. So I'm gonna assign the result, basically the output, as 0 first. So I would say for node in map, so for every single node in the map that we created here, is that if node not in visit, so this node have not visited yet, what I'm gonna do is I'm gonna add the node to the visit set, and I'm gonna run the buffer search on this node. And then every time when I run the buffer search, and I'm gonna add result to 1. And then after the entire for loop, what I'm gonna do is return the result here. And let's see. Okay, yeah, it accepted. Yep, it's accepted. And if you like my video, please give me a thumbs up and subscribe to my channel, and I'll see you soon. Bye bye.